Hi, and welcome back to the course, R for Journalists. In this section, we're going to do a case study doing some spatial analysis. We're going to take what we've learned so far and do some analysis of traffic stops. So we're going to figure out which town and census tract each stop occurred in, and then pull in demographic data from the census to determine what types of neighborhoods police tend to pull people over more in. So you could conduct this analysis using software like ArcGIS or QGIS, but we're going to use R to do it all. For me, it's better to stay in a single environment, from data importing to analysis to exporting visualizations, because the produced scripts make it easier for others, including your future self, to replicate and verify your work in the future. And plus, I might be able to apply this code maybe to another town, which I think we're going to try to pull off at the end of this case study. So, let's start with the data. It's raw traffic stops between 2013 and 2014. Alright, so actually, let's see if I can double open this up. So these are all the traffic stops in the town of Hamden in Connecticut. It's a ton of data. It's wonderful because it includes race, includes reasons for stops, and many other factors like whether or not they were pulled over, and reason for being pulled over, and such. So the state of Connecticut collects this information from all police departments, but only a handful of them include location-specific information. So the researchers at Central Connecticut State University Center for Municipal and Regional Policy geolocated as many as they could, focusing on 8 departments that showed signs of racial profiling that they've looked at before. So about 34,000 stops were geolocated. And we're going to look specifically at Hamden for this case study. So about 5,500 stops. We might revisit the towns later. So let's load the packages and data we'll need. We'll use Tidy Census, ggplot2, dplyr, SF, and reader. And we'll call it stops, and we're going to bring in read_CSV, and it's under case study for me. Data/Hamden stops.csv. Okay, 5,500, 49 different variables. It's a lot. So let's get rid of some of the bad data where there was no latitude or longitude. Don't worry, that's just 2% of the data. So first we'll start with stops and filter, stops and intervention, location, latitude, doesn't equal 0. We want to keep everything else. Oh, okay, well, let me create a new data frame called stops. And now when I run it, I've dropped about maybe 100 stops. So let's map out what we've got. Let's download the census tract shapefiles in Hamden's county, which is New Haven County, with Tigris. So library Tigris this time. Set the SF option. And New Haven is what we want to download. It's what we want to put the download to. So tracks is the census tracts. State equals CT. County is New Haven. CB equals true, because we don't want a big file. And now we have the shapefile, and we have traffic stop locations. And they're all in stops. And where's the latitude and longitude in here? Intervention, location, latitude, intervention, location, longitude. Okay, keep that in mind. So let's map first the layer for the shapefile for New Haven. Gplot New Haven plus geom sf plus geom point. Data is stops, comma AES x equals intervention location longitude. and then y equals intervention location latitude, parenthesis that, and then comma, I want all the stops to be the color red. Plus that, what next layer do we want? My themes. Theme void. Theme panel dot grid dot major equals element line color equals transparent, and give it a label, labs traffic stops in Hamden. Select and run. Huh. Glimpse stops. Intervention. Did I spell this wrong? Yeah, I did spell it wrong. Okay, try it again. Keep spelling things wrong. Longitude. There we go. Why didn't the title show up? Oh, title. Alright, so it's a start. If you have a data set with latitude and longitude information, it's easy to just throw it on a map with a dot for every instance. But what would that tell you? You can see the intensity of the cluster of dots over the area, but that's it. If there's no context or explanation, it's a flashy visualization, and that's it. So there's another way to show you how to do this. One way is to visualize the distribution of stops. So we'll use this function called stat_density2 with ggplot2. So let's see, ggplot. This time geom sf data equals New Haven, because we're gonna do layers. First, we're gonna start with this one, the shapefile. Color equals black for the boundary. Fill equals transparent, so I'll leave it NA. Size equals 0.5. Plus, and this is the function, gstat density 2D. Data is, we're passing it as stops. Show.legend, nah. So f, comma, AES is x. Just gonna copy and paste this. Latitude and longitude, comma, fill is going to be the level of it. So it's detecting the clusters of it. Level, comma, alpha, how transparent do we want the outsides? Same thing as level. Geom equals polygon, size equals 4, bins are 10. How much do we want it to group them up and divide them by? Plus scale, fill, gradient, low, we want the color to be deep sky blue too. High will be, let's give it a fire brick 1, and we'll name it distribution. Plus, and we're going to limit where, because when we made the map before it was really zoomed out, so now we can fix that, right, by setting the scale. Chord sf xlim this time equals c of negative 73.06, let's say, and then between 73 and 72.74, comma ylim, give it a limit of c of 41.28, comma 41.48. Plus, labs is x equals null, y equals null, comma, title is Traffic stops distribution around Hamden. Subtitle equals null. Equals caption is source is data.ct.gov. And then give it my themes. Plus theme panel.grid.major equals element underscore line color equals transparent. And I'm going to be missing a parenthesis somewhere. I know it. Yep. Okay, so where did I screw up? Stat density. Oh, it's after the alpha. No, this is right. Geom, polygon, bins, 10, scale fill gradient, chords SF. Yeah, that's probably where. No, that worked. Labs, theme, panel. Huh. Alright, I'm gonna cheat and just copy and paste my code over. Alright, that's kind of boring. I could break it out by race by using facets. You know what? Yeah, okay. I don't think it'll be too difficult to do. I still don't think that'll be really worth it, but okay, we'll give it a shot. But I'm not that impressed with this heat map. Okay, I guess neither are they. Oh, you know what? I need to first bring that data in. So, okay. We're going to need to use this data eventually, so let's go ahead and get to it. I'm going to first start out with this, creating a race column. Stops, race is... What do we have for stops? The race is... table, stops, subject ethnicity code. So that's Hispanic or no. And then we have race, subject, race code. Okay, so you see we got Asian, black, white, and then Hispanic is in another column entirely. So this is kind of similar to how the census operates with their data. So we need to like create another column that incorporates all that. So we'll create a new column called stops race, and we'll do an if else. Stops subject ethnicity code equals H, then it'll be an H. Otherwise, it will be whatever it was originally. No, you know what? Otherwise it'll be race code, yeah. So let me explain why. So if this is Hispanic, then it should be Hispanic. But if it's not Hispanic, then it should be automatically whatever it is in the race code. So, right? So it's simplifying it. And now I can spell it out. Stops is stops, and I'll do a mutate in case when. Race equals case when. Race equals A. Asian. Race equals B. Black. Race equals H. Hispanic. Race equals W. Then it's white. Okay. No, this should have been right. Oh, maybe I need to run this one first. Okay. Huh. Case when stops race, stops mutate race equals case when race equals A. Oh, I don't need the commas. There we go. Okay. Check out those new columns. They are accurate. So I think that's what was missing when I did this earlier. There we go. We're making 4 maps. Okay, I've combined maps. Sorry. Let's try this one more time. Guess I'm going to put it in the right spot. Okay. We've broke out a heat map for facets, for small multiples for Hamden, and we see the distribution of Asian where they're stopped. Blacks are stopped in this area, Hispanics is more broad, whites more broad. So, I'm still not really satisfied with this map. We got to go deeper. We want to look specifically at which neighborhoods police tend to pull people over more often and compare it to demographic data from the census. So we're going to need to count up individual stops and locate them to individual neighborhoods. So we'll do that in the next video, but for now, let's stop and pause. I'll see you then.